Hi guys, welcome back to our mathematics tutorial. This is implicit differentiation and we are on example number 13. So example 13 says y equals to the square root of x plus the square root of y plus the square root of x plus the square root of y plus the square root of x plus the square root of y and so forth. So what do we notice? We notice that the square root of x plus the square root of y, this set is the one that is repeating. So it means that from here all the way to infinitive is just the same thing that is repeating. So this thing that is repeating that is in this portion, right? Is also y. Because if you continue with this thing, it will include this one and so forth. So this whole portion is also y because this is repeating x. So it is not only x that is repeating, but x is repeating with y. X the square root of y plus the square root of x plus the square root of y and so forth. It's like alternating. So if this is equal to y, we can rewrite it as y equals to the square root of x plus the square root of y plus, so this whole portion now is just y. So what do you observe? Y plus y gave us 2y. X plus square root of 2y. Then we want to solve for y, so we can square both sides. We want to have y squared is equal to x plus the root of 2y. So we send this x across, y squared minus x. And then we can also square both sides to get rid of this square root. So you have y squared. So we expand y squared now. So it's y squared minus x times y squared minus x. So y squared times y squared is y to the fourth. Y squared times x is x y squared. X y squared is x y squared. And then x times x is x squared. Negative times negative is positive. All must be equal to 2y. So right between here is, if I like terms, y to the fourth minus 2x y squared, and then plus x squared equals to 2y. So we can now find its derivative. So y to the fourth now is just equal to 4y to the third power. We reduce the power. So right here we have product rule because you have x and y being multiplied by each other. So this is minus 2. We hold on to it. So we hold x and differentiate y. We get 2y. And then we attach y prime. Plus, we hold on to y squared and differentiate x. We just get 1. So this is just y squared. The derivative of x squared is 2x. The derivative of 2y is equal to 2. Then we attach y prime. So all of those terms of y prime can be grouped on one side of the equation. So in fact, the first term is just 4y cubed, and then we attach y prime. So this is 4y cubed, y prime. So we multiply, this is minus 4x y prime. This is minus 2y squared. 2x is equals to 2y prime. So these are all of the terms with the prime. So we have 4y cubed minus 4xy. We send this one across, it becomes minus 2. So we just factor out the y prime in each of these terms. All equals, if this goes across, it becomes positive 2y squared and minus 2x. So we can divide all sides now by this expression. So y prime would just be equal to, now in the numerator, we can factor out 2. So it's y squared minus x. And down here also, we can factor out 2. So it's 2 outside. We just have 2y cubed minus 2xy, and then minus 1. So this 2 can cancel this 2. So we're just going to have y prime to be equal to y squared minus x all over 2y cubed minus 2xy minus 1. So this is the answer. If you like, you can replace. It's too long. I'm not going there. So for the fun, you can just replace y within the expression, right? Just replace y. So let's do it. So we replace, and we take this expression and replace it with y. What do you observe? You observe that if this square is applied on this square root, the first square root will go out. So it means this x and this x will also go out. What do I mean? I mean, if you have it like this, you have x plus the root of y plus the root of x plus the root of y plus the root of x plus dot 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 all the way to infinitive, all square, and then minus x. So if this is square, it means this first term will be out, divided by 2 again. Wow. So terrible. So for this one is just 2. This y cube, just replace this y with it. It's too long. So it's just 2 the root of x plus the root of y plus the root of x plus the root of y plus the root of x plus dot 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 all the way to infinitive. It's too long. So this raised to the third power minus 2x, and then x plus the root of y plus the root of x plus the root of y plus the root of x dot 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 infinitive. And then minus 1 at the end. Minus 1. So this is actually the problem. If this square root can cancel this first one, so it means that the square root will be no more. The first square root will be no more. And what happens? This x can cancel this x. So we would just have this expression like this in the numerator. So this is it for this problem. And thanks all so much, and see you in our next class. Thank you.